Okay, so today we are starting Unit 9, our last unit of the year. And before we begin, I want to review some of our properties of exponents because we're going to need them as we solve our equations. Let me just grab a better pen here. So first, I want to talk about P-man. Okay, so both of these are going to be P-man here, where we remember that if I have a power to a power, if I have a power to a power, then I multiply my exponents. Okay, if I have a power times another power, if I have multiplication between my powers, then I'm adding my exponents. Okay, so for example, if I have x to the 5th to the 3rd power, we know that that's going to become x to the 15th power, versus if I have x to the 5th times x cubed, that's going to become x to the 8th. So here I'm multiplying, here I'm adding. The last property that we'll see is with our negative exponents. So that x to the negative 1st power equals 1 over x, okay, or vice versa. And for that, we talked a lot about cross the line, change the sign. So if I had something like x to the negative 2nd y cubed, I would have left the y cubed in the numerator and I would have moved the x to the denominator, and that would have gotten rid of my negative exponent, okay? And for what we're doing now for our exponential equation, we're actually going to be working opposite of that, where I can take something from the denominator and bring it to the numerator, and it's just going to make that negative. Okay, so just knowing that we can kind of work both ways there. So we're starting a unit with exponential equations. What's different about these equations from equations that we've seen previously is that the variable term is in the exponent. Now, there are all sorts of exponential equations. We're only going to look at a certain type, which we're able to solve using what's called base matching. When you get to algebra 2, you actually start solving exponential equations with things called logarithms. We're not getting into that, but just kind of knowing that we're looking at a specific kind of exponential equation. There's others out there that we wouldn't be able to solve using the property we're going to use for today's notes. Okay, that's like in your future. So the property that we use to solve our exponential equations is called the equal base property, or I like to just call it base matching. And that property says that if b to the x equals b to the y, then x must equal y. Okay, that these exponent values must be the same. So for example, really basic example here, if I have 2 to the x equals 2 cubed, so same base, right, and my bases match, same base here as well, then it would make sense that this variable x would have to be 3. If 2 to the x equals 2 cubed, then this has to also be a 3. So there'd be 8 equals 8 on both sides. Okay. Now the equations that we're looking at are not going to be quite as direct as this. But our first example looks very similar to that that I just wrote up above here. So 2 to the x equals 2 cubed. Well, okay, well then x equals 3. Our first example says 2 to the x equals 8. And so what we do to solve these exponential equations is we rewrite the equation with the same base for everything. So I'm going to just rewrite 8 as 2 cubed. And now it becomes crystal clear, right? X, okay, so x must equal 3. And then same idea here. I can rewrite 9 to have a base of 3. So I have to figure out what base they all have in common, what I can write all of my terms as the same base. And now if 3 to the x equals 3 squared, well, then this variable x must equal 2. 5 to the x equals 1/5. So for this one, that's using that negative exponent property, and we're going to use it backwards. So I can write 5 to the x equals 5 to the negative first. And so what I'm doing is I'm taking this 5 to the first in the denominator, and I'm moving it back up into the numerator. And so that would make that negative. And then I can say, oh, okay, x equals -1. Now the next one's a trick question. So it's 4 to the x equals 0, and we can't rewrite 0 as a power of 4. And if I think about my exponents, if I had like 4 to the negative first, we know that's 1/4. 4 to the 0, anything to the 0 power, again, going back to properties of exponents, was 1, right? And then I have 4 to the first, which is 4, 4 squared, which is 16, and so on. And if I went even more negative, I'm just going to get smaller fractions. Okay, 4 to the negative second is 1/4 squared, or 1/16. So you can see I'm never going to hit 0 here. Okay, negative exponents are just going to give me smaller fractions. Positive exponents are going to grow exponentially the other way. And having an exponent of 0 always gives me 1. So this, we're just going to have no solution here. Okay, there's no exponent that I could raise 4 to and have the result be 0. So on our next one, very similar to this, but now I have 2 and 16. Can I rewrite 16 as a power of 2? And I can. So this is 2 to the x equals 1/, instead of 16, I could write that as 2 to the 4th. So instead of 1/16, that's 1/2 to the 4th. Or 2 to the -4th if I brought that from the denominator up to the numerator. And now I have my bases are matched, and I can say that x equals -4. Okay, so our goal here is all about getting the same base for all of my terms. On our next one, notice that I have a 2 here. I can't rewrite 2 as a base of 4, but I can rewrite 4 with a base of 2. So I'm going to take 4 and write it as 2 squared, but that 4 was being cubed, and this is where our properties of exponents come into play. So instead of 4 cubed, I'm going to think about it as 2 squared being cubed. And then properties of exponents, going to P-man, power to a power, I multiply those exponents. So really I have 2 to the 6 equals 2 to the x. And then x must equal 6. Take a moment and think about this next one. Is there any power of 3 that gives us -9? Or is there any way I can write -9 as a power of 3? No, there isn't. Because what people want to say is -2. That if I had 3 to the -2nd, it would be -9. It wouldn't be. 3 to the -2nd is 1/3 squared, or 1/9. Okay, this is another example of one. So there is no way that I can rewrite that negative number with a base of 3. Because 3 to any power is never going to give me a negative. It's either going to grow exponentially for my positive exponents, or for my negative exponents, it's just going to become a smaller fraction. Okay. So now before we look at trickier problems, see if you can rewrite the next two so that they have the same base. And you're going to have to use some properties of exponents here. So look at the one above it for some help. Don't move on to the next page yet. Just try those next two. So pause it and try them, and then start the video again, and we'll compare notes. Okay, so on the first one, I have 5 to the x equals, and I can rewrite 125 as a power 5. That's 5 cubed. Because it's in the denominator, if I bring that to the numerator, it becomes 5 to the negative third. And so now I can say, okay, x equals -3. I can rewrite 16 with a base of 2. So instead of 16 squared, I will have 2 to the 4th being squared. I'm just rewriting 16 so that I get equal bases on both sides. And then properties of exponents tell us that we should multiply. So 2 to the 8 equals 2 to the x, then x must equal 8. Okay. So now let's look at some that are a little more involved. Those were pretty direct. We just had to rewrite it and we could see our answer and we were done. It's not always going to be that way. We'll flip this over. Let's look at some that are a little more involved. And I'm going to choose a few to do and then I'll let you try a few on your own. Okay. So on our first example here, now I could use a base of 4 or I could rewrite both of them as a base of 2. Just kind of pointing that out that there's options on this first one. But I don't really want to rewrite this one if I don't have to. So I'll leave this as 4 to the x minus 2, and 64 is 4 cubed. So same idea, right? We rewrote it, so we have our bases matching here. Now the difference is that now I have an expression in my exponent. So before, where we just said x equals 3 or x equals whatever, now we know that if it's 4 to some power equals 4 to some other power, then these powers must be equal. So now I'm going to rewrite just setting the powers equal to each other. So x minus 2 must equal 3. Must be the same. And I'm going to have to do some inverse operations work to solve for x. So x equals 5. Okay, so now I have an expression here that I need to solve afterwards when I set my exponents equal to each other. Let's jump to the third one here. And so 27 and 9. Up until this point, the equations that we looked at, I believe, it was always we could rewrite one side to match the other. We can't rewrite 27 to be a base of 9. But what we can do is rewrite both of those numbers, 27 and 9, with a base of 3. Okay, so it's not always that we're just matching one side to the other. Sometimes we're changing both sides so that they have the same base. So 27 is 3 cubed. So now instead of 27 to the x plus 2, we have 3 cubed being raised to the x plus 2. And then I can rewrite 9 on this side as 3 squared because 9 and 27 can both be written as base 3. So like that's kind of the first step of thinking through how am I going to set up that equation is get the same base. Now we move to, okay, well, what are my properties of exponents? And so for both sides here, I have a power to a power. So I'm going to be multiplying. Now on this side, when I multiply, I need to distribute that 3 needs to go to both of those terms. So I'll have 3, and my exponent will be 3x plus 6. Okay, multiplying those powers together. And then over here, I have 3 to the 2 times 2x gives me 4x. Now I have equal bases on both sides, and I've gotten it down to a single base on both sides. So that's also, as we get further along, like down here, that's going to be part of our goal, getting it down to, okay, 3 to some power equals 3 to some power. So if that's true, then those powers must be equivalent. So now I'm going to take my exponents, 3x plus 6, and set it equal to 4x, okay, because it would have to be the same value in order for it to be equivalent here. And I subtract 3x, and I get 6 equals x, or x equals 6. Okay, so now I want to jump to one that's a little more challenging. And so let's go to this third row, first column right here. And kind of, it's not going to be Nothing's changing here. It's just we have more terms that we need to adjust and again, get that same base. So if I have 25, 125, and 5, 1/5, I can rewrite them all with a base of 5. So starting with the 25, I'll rewrite as 5 squared. So I have 5 squared to this power of 2x plus 1 times 125, I can rewrite as 5 cubed. 1/5, I can rewrite as 5 to the negative first. Okay, so now I've taken my original equation and I rewrote everything with the same base. Now it goes to those properties of exponents. So where I have a power to a power, I'm going to, I'm going to be multiplying. And for both of these, again, I'll need to distribute through. So this will give me 5 to the 4x plus 2, still have times 5 cubed, equals 5 to then I have to distribute that -1 through. So just being really careful with our signs, that's going to give me -4 plus x. Now, unlike before, right now I have 2 terms equal to 1 term, and I need to get it a single term equal to a single term. So for this step, now we have multiplication of the same base. And when we have multiplication of the same base, we add our exponents together. So I can condense this to a single base of 5 and write it as 4x plus 5, just adding the like terms, 2 and 3 together, equals 5 to the -4 plus x. Now that I have it down to 5 to some power is equal to 5 to another power, those powers must be equal. So I can say 4x plus 5 must equal -4 plus x. And now I'm solving. So maybe I subtract x. I'm running out of space here, giving me 3x plus 5 equals -4, or 3x equals -9, and x equals -3. Okay. Let's jump to the last one in that row. Okay. So I have 4, 1, 8, 4, and 2. And again, that first thought you have is, what can I rewrite? How can I rewrite it so they all have the same base? And what we would have to go to here is rewriting them all with a base of 2. So the 4, notice there's an x squared here, is going to become 2 squared to that power of x squared. 1/8, so 8 is 2 cubed. 1/8 would be 2 to the -3rd power, x power, times 4, again, rewriting that as 2 squared to the 1 minus x, times 2. And I'm just going to write that that's 2 to the 1st, so we don't leave out that exponent when we get further along. So I've taken my equation, I've just rewritten the equation with same basis. Now, properties of exponents, so start with our multiplication, right? So power to a power, multiply. This is going to become 2 to the 2x squared, multiplying -3 and x, 2 to the -3x, times, here I need to distribute that 2 through. So times 2 to the 2 minus 2x, times 2 to the 1st. Now on the left-hand side, I have it down to a single term, but on the right-hand side, I have 3 terms here. And we know that P-man tells us that when we have multiplication of the same bases, we can add up our exponents. So I'm just going to combine like terms. So I'll still have 2, the 2x squared over here. And on this side, I'll have 2 to the, in terms of x's, if I'm adding up like terms, I have -3x and -2x. So I have -5x altogether, adding up those like terms. And this is why I wrote it as 2 to the 1st. And then I have 2 and 1 for my constant term. So I have +3. Okay, so what I've taken is these 3 exponents, these 3 powers, and I've condensed it down to 1 power using properties of exponents and just adding my exponents together. Now I have 2 to a power equals 2 to a power. So these powers must be equal. These exponents must be equal to each other. So I can take from here and write that 2x squared must equal negative 5x plus 3. And it's a quadratic. So to solve a quadratic, I'm going to get it set equal to 0. I'm going to try to factor, and if I can't factor, then I would move to the quadratic formula. So let's see here. If I can factor this, so 2x and x, and if I go 3 here, 1 here, has to be opposite signs. So I'm going to make it positive, negative. That gives me positive 6, negative 1. Okay, so we still have this quadratic unit, it's not going away. So this equation, we're going to have 2 solutions here. We're going to have x equals, I'm going to just write it up here, 1/2, and x equals negative 3. Okay, those are my 2 solutions for x. So now I think we've done enough of these for you to try a few on your own. So I've left quite a few. Let's see, I've left 8 problems for you to try on your own. Obviously, they kind of get progressively harder. This last row being having kind of a lot of things to combine. But use the examples you've done so far to help yourself as you go through. And I really want you to try this on your own before continuing the video. And I'm going to just fill in answers so you can check your work. And we'll talk more about it as a class tomorrow. But really try to use the examples we have, set these problems up, getting the same bases and solving from there. And then when you're done, play the video and I'll just kind of show you the answer key. Okay, so let's just look through the answers of the ones we didn't do together. We had done, you should have done this one on your own, and be careful there when you write 2 to the negative first, that's going to flip around your sign. So if you had something wrong there, might have had to do with that. This one's a little tricky because you have a fraction divided by a fraction. So remember, dividing by 8 is the same as multiplying by 1/8. That's how I get the 5/16. We had a quadratic here, and then just solving there. You had done this one on your own. It is a funky answer of 13/19. And you solve there. And then this last row, this last one, actually, I meant to make it factorable, but put in the wrong, didn't change the problem that I meant to change. So it's not factorable, it's a quadratic that's not factorable. You would have had to use the quadratic formula to get your answer. And so a little bit tricky there. Don't expect to see that. Hopefully I've changed any others that are like that in the future. Okay. I'll also scan this in with the notes so you can take some more time to kind of compare notes if you are not getting these answers and maybe see where you went wrong. Again, all about properties of exponents. Like this one's a good example to look at. Rewrote them all as a base of 6. Multiplying exponents here, you have to distribute through, and then adding. So I'm combining like terms, 2 and negative 4x, 2 and 2. Now I can set my powers equal to each other and solve.